Hi, my name is Prachi Jain. I am a postdoc at MSR India. I welcome you to the tutorial session where we will perform a bias audit of an NLP dataset produced by crowdsourcing. Language is a primary means through which stereotypes and prejudices are communicated and perpetuated. These biases easily translate to the language, text, content that we write. This may This takes me to our activity where we answer, can such bias also exist in crowdsourced datasets, which are extensively used in NLP research nowadays? What are the ethical implications of soliciting crowdsourced data, specifically social biases that may emerge when asking for generated sentences? So, in this hands on session, as I already promised, we will be doing a bias audit of a popular NLP dataset which is produced by crowdsourced workers. You will attempt to measure the presence of social stereotypes in this dataset, and after this analysis, we will present specific examples from the data that we speculate could be particularly biased and problematic. So, we will be focusing on SNLI corpus in this task. However, there are many other NLP corpus which are built using crowdsourced annotations. You are free to go and analyze those data sets too. But here we'll focus on SNLI corpus. So first, what is NLI? Natural Language Inference. It is also known as Recognized Textual Entailment, RTE, and it is basically a task of determining the inference relation between two short and ordered texts, whether one entails the other, whether one contradicts the other, or they have a neutral relationship. The corpus that we look at has about 570,000 human written English sentence pair manually labeled for balanced classification with labels like entailment, contradiction, and neutral. Here is a snapshot of the SNLI dev set. For example, a man inspects the uniform of a figure in some East Asian country. The man is sleeping. The two sentences contradict one another. While something like a soccer game with multiple males playing, it clearly entails something like some men are playing a sport. Now, how was the dataset built? For the premise and for the hypothesis, two different set of crowdsourcing effort was performed, and hence two different set of crowdsourcing instructions were given. For the premise basically came from Flickr 30K corpus, which is a collection of about 160,000 captions corresponding to about 30,000 images, and the captions were not authored by the photographers who took the source images. And for hypothesis, this is a picture of the instructions which were actually given to the crowdsource workers to write a sentence which is either contradictory or either entails, or it's neutral through the given set of captions which we have in the premise. So a little more detail on the resources that we will be using. We will be using the trained set of SNLI 1.0 corpus, which has sentences with premise and sentences with hypothesis, and with sentence 2 are the ones which the users came up with in the crowdsourcing exercise for this particular corpus, and sentence 1 was from Flickr dataset. And we also provide a list of identity labels like men, women, basically, the things that you would like to analyze and which are prone to some kind of societal biases. Yeah. The tool that we'll be using to analyze or find if there is any bias in the dataset at all is point-wise mutual information. The broad idea of PMI is that it can measure word associations in a corpus. That means how frequently two words co-occur above what might just be expected based out of their frequency. And yeah, and we've already given you a set of identities that you can use. The formula of PMI looks like the following. It is log base 2 of the ratio of the bigram probability of word I and word J divided by product of unigram probability of both the words. For word association analysis, finally we will have a function which will take a unigram that we are interested in along with the word frequency related to the corpus, the unigram frequency and the bigram frequency, and it will give out a list of words from the corpus and the PMI scores of those words with respect to the input identity term or the input unigram that you give. So that's the kind of function that we want to write. And we'll also have to do some kind of pre-processing and to get better picture of the data set. Things like we will not focus on words which are which occurs less than 10 times in the corpus, and also we'll be doing pre-processing of the form that will lowercase the words in the sentence. We'll remove stop words, tokenization. I mean, these processing are fairly standard, and the prime goal here is that since the data set is small and we want to get the most accurate estimate of probabilities, so we try to do some pre-processing on the data set. Another small thing is that there are some duplicates. Please be wary. Yeah. So finally, after we are able to compute the PMI score of all the words in the corpus with the identity labels. We would like to look at the top most associated words for each of the identity labels and think if they reflect any kind of social stereotypes. There are other very interesting advanced analysis that can be done. It's like you can actually study counterfactual pairs. Counterfactual pairs are basically you have a dominant group and a corresponding minority group, and you compare between the two and you can get a broad list of counterfactual pair from the paper mentioned here. And b- besides that, you can also look at additional corpora which are crowdsourced like MNLI, ROC stories, Quad 2.0, and so on. Other than that, in place of using bigrams, probably you can focus on n-grams or higher grams. Another interesting thing is suppose you're looking at a classification task, sentiment classification task, like you know, angry, happy, right? These kind of sentiments. So it would be interesting to see association of identity words with certain words in different classes, like what happens when the class says it's angry, the sentiment is angry, and when the sentiment is happy. It would be interesting to look at the differences. I mean, also you're welcome to explore new association measures. Here we used PMI, but there are many more that can be used. Also, the bias difference in hypothesis and premise. Note that I already highlighted that the two were built very differently via very different crowdsourcing efforts, right? If there is any difference in the bias in the two set of sentences, and also think what it on in addition can you add in the crowdsourcing annotation guidelines to avoid such biases. Now let's look at the notebook